Here we have another integral that's worthy of a u substitution. The substitution I'm going to make here is u equals the square root of x plus 5. And the reason I'm doing that, you'll see in a second, is before I take this derivative, I'm going to go ahead and rewrite this as x to the 1/2 plus 5. But the reason I'm doing that is because the derivative of x to the 1/2 plus 5 is 1/2 x to the negative 1/2 dx. Or if you rewrite this using radicals, because we know that fractional exponents are kind of weird, let's call this 1 over 2 square root of x dx. And if I solve for dx, I get 2 square root of x du equals dx. And now that I have this, I can substitute this as well as my u equals square root of x plus 5 into the integral. This is going to give me the integral of 2 over square root of x is going to stay the same, but this square root of x plus 5, I'm going to call this guy u. This is being raised to the 4th. dx gets replaced by 2 square root of x du, which is really handy because this root x and this root x end up canceling, and my integral is now all in terms of u. I'm going to clean this up just a little bit before I integrate. 2 times 2 gives me 4. And I'm going to rewrite u to the 4th that's in the bottom as u to the negative 4, so as I can apply that reverse power rule. So add 1 to the power, divide by the new power, and then add c at the very end. One last thing we'll need to do is make sure to replace u by its original substitution, which was square root of x plus 5, which we can write as negative 4 thirds times square root of x plus 5 to the negative 3rd plus c. Or if you want to put this power of 3 down in the denominator, you can very well do that and say negative 4 over 3 times square root of x plus 5 cubed, all plus c.